Good day everyone, my name is Roberto M. Gomez Jr. from BFED 2A. For today's video, we're going to answer the question of Unit 3. So let's start. Question number 1. What are the four essential components of any closed-loop control system? Describe how each of the components might function for a child who is using a crayon to color a figure in a coloring book.
Find a control system. Think of it as a collection of devices that manage or command the behavior of other device or system in order to achieve a desired result. Control loops, which are the process designed to maintain a process variable at a desired set point, are used to accomplish this by a control system. In other words, a control system can be defined as a system that controls other systems, which is a simplified definition of the term. In tandem with the modernization of human civilization on a daily basis, the demand for automation has grown exponentially. Automation necessitates the control of complex network of interconnected devices. Control loop control systems are comprised of four distinct components. Number one, an executive for decision-making about error. Two, an effector system for carrying out the decision. Three, a reference of correctness against which the feedback is conferred to define an error. Four, an error signal which is the information acted on by the executive. All of this would function by visual information about the crayon in her hand relative to the figure in the book represent the feedback. Differences between coloring in the lines or out of them are sensed as error. An executive determines the correction by coloring in the lines of the figure.
Diagram of an open loop system that we have already discussed in the previous lecture, and we know that the open loop systems are internally divided into two different sections. One is the controller section, which controls the amount of input that is required for the desired output, and the process section processes the input in order to generate the output. But the major disadvantage in case of the open loop systems is that it does not know when to stop, or it is not able to handle the disturbance. We took one example of an immersion water heater in the previous lecture, and we know that if we put the heating rod inside the water and we turn the switch on, then the immersion water heater starts heating the water, but it does not know when to stop heating. Or we can say that open loop system does not know your desired output, and that's why it goes on heating the water until you turn the switch off. So in order to maintain the desired output, we need to measure the output continuously, and we do it by using a feedback signal. In the closed loop systems, we can say the output is measured continuously and is fed back to the input, where the error with respect to the desired output is determined. We call this unit as the error detection unit. And then after that, the signal goes to the controller. The controller then controls the amount of input according to the desired response, and then the control input goes to the process section, and hence we get the desired output. And this time, the desired output is maintained. And in this way, the presence of feedback compensates for the disturbance, and it improves the accuracy of the system. An air conditioner is a very good example of a closed loop system. It continuously monitors the temperature inside the room, and accordingly, it turns off and starts over the compressor which is present outside the room. And in this way, it maintains the desired temperature. We can have one more example of a geyser. A geyser is a water heater, but here we can set the desired temperature. It continuously monitors the temperature of the water present inside, and it turns off and starts over again in order to maintain the desired temperature. Whenever the desired temperature is achieved, the geyser will turn off, and after some time, when the temperature decreases, it starts over again in order to maintain the temperature. So now we're done with the introductory portion of closed loop systems, and now we will have a comparison of open loop systems and the closed loop systems.
So in the video we watch, we can see the four essential components of closed loop system. So now let's discuss first the executive in our body, the brain in our control system, right? So the four essential components, the executive is our brain or control system because it have as two things to learn. So in a given scenario, the executive functions to help the child think how or he start coloring the book. So dito sa executive, iniisip na ng bata kung paano niya kukulayan ang book. The second one is effector. After we about think we are going to do, the effector will come, or this is the next auxilium procedure that we are going to do the actions needed. So for example, sa executive, alam na ng bata kung ano yung gagawin niya. Dito sa effector, niya ang naisip niya. So kanina naisip niya kung paano niya kukulayan. So ngayon, i-act niya kung paano niya ito gagawin. So yung function ng effector, i-act niya na yung naisip niyang gawin. So the function of effector is to help the executive to do tasks, the effectors, the drivers, the feed formation to the system. The third is feedback. This scenario, the function of feedback is that the result of what the executive effector This will be the final output of the executive and effector. The reference to feedback simply means that some portion of the output is returned back to the input to form pair of the system. Excitation feedback system are used to control, regulate process, and the last part is comparator. The function of comparator in this scenario is confer whether what the executive and effector and feedback need compatible or correct. In short, here we can see if the child did correctly what she had in the mind and the action we need.